Okay, in this video we're going to learn how to do dilutions. And dilutions are still working with concentration, but they're based on the idea of molarity and volume. And the formula that we use for dilutions is M1V1 equals M2V2. M1 refers to the first molarity, V1 referring to the first volume, and we're multiplying those together. M2 being the second molarity and V2 being the second volume. And so the way that we use this equation is that we will be given three values, and then we are looking for the fourth variable. We'll circle the variable that we're wanting, and then we'll divide its partner over to the other side. All of this is based on the idea of molarity. And so let's kind of talk a little bit about molarity. We know that molarity is a measure of concentration. So if I add more water to something, the volume will go up, but the molarity or the concentration will become less concentrated. You can think about that by taking like Kool-Aid concentrate or orange juice concentrate and adding more water to it. The volume went up, but the concentration went down. So if we increase the volume, we know that we will be decreasing the molarity. The flip side is also true. If you have a solution and you take the water out of it, you're going to be decreasing the volume, so that means that it will become more concentrated or increasing the molarity. And we're going to use these relationships to predict the answers in our problem. So we're going to be looking at the worksheet on page 7 in our notebook called dilutions. On one side of the worksheet you have problems 1 through 5, and on the other side of the worksheet you have problems 1 through 4. We're going to start on the side that has problems 1 through 5, and we're going to be looking at problems 3 and 4. So let's look at those. Problem number 3 says, how much of a 0.5 molar HCl solution can be made by diluting 250 milliliters of a 10 molar HCl solution? So we know that we're going to be taking 10 molar and we're going to be reducing the molarity or making it less concentrated all the way down to 0.5 molarity. So if I'm just thinking about it, if it's going to become less concentrated, I'm going to have to add a lot of volume. And I can look up here and see if it becomes less concentrated, the volume should go up. So my answer should go up from 250, but we're going to see that. So I write down my equation, M1V1 equals M2V2, and I'm going to look in at my problem and I'm going to look at the numbers. So I see that I want to know how much of a 0.5 molar HCl solution can be made by diluting 250 milliliters of 10 molar. Well, 250 milliliters is my initial volume, so that's where I'm starting out at. Now we notice that it's in milliliters. That is okay when we're doing the M1V1 equation. We can keep it in milliliters as long as it's in milliliters for both volumes. So 250 milliliters of a 10 molar solution. Well, that's my initial concentration, or M1. I'm changing the concentration down to 0.5, that's my M2, and I want to know how much. That is my V2. So I'm going to be looking for my second volume. So I circle V2, and in order to get it by itself, I divide both sides by M2. So I'm going to have M1 times V1 divided by M1 times V1 divided by M2. So let's go in and let's put that information into our problem. So M1 times V1 divided by M2. Okay, so let's get those numbers from our problem. M1 is 10 molarity, and V1 was 250 milliliters, and we're going to divide that by molarity 2, or 0.05 molarity. My m's will cancel out, so I'll be left with milliliters, and so let's put that into our calculator. 10 times 250 divided by 0.05, and I get a really large number, 50,000. The unit I would have would be milliliters. 50,000 milliliters. So I have to ask myself, does this answer make sense? Well, I know that I went from 10 molar, that's really concentrated, all the way down to 0.05, that's not concentrated at all. So my molarity went down by a lot, so my volume should go up by a lot. And it did. It went from 250 up to 50,000. So I have both of these as my answer. I have my numerical answer, and then I have my justification. Because the molarity went down, the volume goes up. It's an inverse relationship. Okay, let's look at number 4 on the same side of the worksheet. So we're still on the worksheet, the side of the worksheet that has 5 problems, and we're on number 4. All right, number 4 says, I have 350 milliliters of a 1.5 molar NaCl solution. If I boil the water until the volume of the solution is 250, what will the molarity be? So let's think about it. I have 350 milliliters of 1.5. And I'm going to boil the water. That means the water will evaporate, and the volume is going to go down to 250. Well, if the volume goes down, the molarity should go up. What's left should be more concentrated. So I should predict an answer that is greater than 1.5. Let's plug it in. I'm starting out at this volume and this molarity, and I want to know what will the volume be. That's going to be V2 of 200 well, if I boil the water until the volume is 250, so that would be V2. What will the molarity be? And I'm looking for M2. Okay, so just to kind of go over that again, volume 1, molarity 1, and I want to know if I boil it until the volume of the solution is 250, V2, what will the new molarity be, the new concentration, M2? So M1V1 equals M2V2. I'm looking for M2, so I circle it and I divide its partner. So it's going to be M1 times V1 divided by V2. M1 times V1 divided by V2. So I plug in my numbers. M1 was 1.5 molar times V1, which was 345 milliliters, divided by 250 milliliters. Cancel those out, and so I am left with 1.5 times 345 divided by 250, and the answer that I get for that is 2.07 molar. So let's go back and see if that makes sense. My volume went down, so my molarity should go up. And it only went down a little bit, so my molarity only went up by a little bit. So if my volume goes down, my molarity should go up, and it did. It went from 1.5 to 2.07. So my answer is correct. Last problem. Now in the last problem, we're going to flip our worksheet over. We're going to be on the side that only has 4 problems, and we're going to be looking at the first problem. So the first problem says, if I have 340 milliliters of a 0.5 molar NaBr solution, what will the concentration be if I add 500 milliliters more water to it? Okay, so again, M1V1 equals M2V2, and let's look at our problem and let's think. Okay, so if I have 340 milliliters, first volume, of a 0.5 molar solution, that is my first molarity. What will the concentration be if I add 500 milliliters more water to it? Okay, this is where it gets a little interesting. I want to know what will the concentration be. That means I'm looking for M2. But it says here if I add 500 milliliters. Well, that's going to be something a little bit different. What most people are going to want to do is they're going to say, oh, 500 milliliters, that's V2. But it's not saying that at all because it's saying add. So if I started at 340 and I add 500 added to the 340 gives me 840 milliliters. That is my V2. And again, that's because it had the keyword there, add. So let's put this in. M1V1 M2V2. I'm looking for M2, so I'm going to circle it, cancel the partner over. M1V1 divided by V2. Let's plug in our numbers. M1 is 0.5 molar. V1 was 340 milliliters divided by V2, which is now 840, because remember I added the 500 milliliters. And I'm going to predict that since my volume went up, my molarity should go down. It should become less concentrated. So let's see what happens. 0.5 times 340 divided by 840 equals 0.2. 0.2 molar. So my volume went up, so my molarity went down. Volume up, molarity down. And that would be my answer. So this is dilutions. And remember, whenever we do dilutions, we're going to have M1 times V1 equals M2 times V2. And we know that it is an indirect or inverse relationship between volume and molarity. Now, there's always some confusion on, well, when do I use this equation? It's kind of easy to figure it out. See how there are 4 variables in this? Your equation will always give you 3 of the 4 variables. Now, with the other problems, like with molarity, because there are only 3 variables, you'll be given 2 numbers. So anytime you see 3 Numbers. You know that you're going to be using M1V1 equals M2V2. Anytime there are three numbers, and remember we circle the one we're looking for, divide out the partner, and solve. We always justify, remembering that we should have an inverse relationship.